Today we're going to be looking at section 1.1 number systems. Our learning target is to examine and understand all components of the real number system. So we have some definitions to start with. First we have natural numbers. These are the counting numbers. So starting with 1 and then counting up by 1, 2, 3, 4, etc. all the way to infinity. Next we have the whole numbers. So whole numbers just add 0 to the counting numbers. So starting with a 0 and then 1, 2, 3, etc. for into infinity. Then we have integers. So now we're going to add in the negative counting numbers, but it still has to be like -1, -2, no decimals in between. So these would be all the way down to negative infinity, -3, -2, -1. It does include 0, 1, 2, 3, and then going up to positive infinity. Next, we have rational numbers. So these are all numbers that can be written as a fraction. And if they're in decimal form, can it be converted into a fraction? So for these integers, if you have a number, let's say two numbers, m over n, the bottom cannot be, the n cannot be a 0. So the number on the bottom can't be a 0. If it's a fraction already, it's easy to pick out. However, if it's written as a decimal, there are two different decimals that can be changed to fractions. One is a terminating decimal. So what does that mean? It means that if you look on your calculator, it has an end point. It doesn't fill the whole screen. So for example, 0.25, and then that's it. It's done. It ends. And we know that can be converted to 1 over 4. So if it's a terminating decimal, it means it has a fraction that it can be changed into. And also a repeating decimal. So for example, 0.3333333, so you can say this as, you can put the bar on top, meaning it repeats, and this can be changed into a fraction, so this is a fraction 1 over 3. Sometimes you can have more than one number that repeats, like you could have something like 0.263263, so a series of 3 numbers. It's still a repeating decimal, so that would count as a rational number. Or anything that's written as a fraction already. So I don't know, 10 over 3 or 9 over 2. Okay, if it's already written as a fraction, that's also a rational number. Irrational number is everything else that cannot be written as a fraction. So for example, if it's a number that like continues on with all sorts of different decimals, so 1.32478, blah, 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 keeps going. Okay, 3.7246, etc. It keeps going. You can also say symbols that represent numbers. So for example, pi. Okay, so pi is also a number, 3.14, and then it continues on with lots of different decimals. It can be square roots. So like if you put the square root of 2 into your calculator, you would have a screen filled with decimals. Now you have to be careful with roots because sometimes, let's say you had square root of 4. Well, that would be 2. So that would actually be a natural number. So you always, if you're ever given a square root, you always have to check them in your calculator, or if maybe you know them off by heart, but to make sure where they fall in here. And the last thing we have is real numbers. So all the numbers that we're going to be talking about here are all real numbers. And just to contrast that, if they're not real, okay, then they're called complex, or otherwise known as imaginary. And that's something that you won't see until university, okay? So just to see how these fit within each other. So everything is real numbers. Then real numbers branches into 2. So we have the rational numbers on one side. So remember, that's the fractions or things that be turned into fractions. And then you have the irrational numbers on the other side. So those are decimals that continue on forever. And then within rational numbers, a smaller subset are integers, so negative, 0, and positive numbers. Then smaller subset of that are whole numbers, so 0 and positive numbers. And then an even smaller subset of that are the natural numbers, so positive counting numbers. So here we have a bunch of numbers, and the question says, where do these numbers belong on the diagram of real numbers? Okay, so we have to place them. Now, first we need to look at anything that has a root in it, and we need to see what it converts to. So this is 4 root 2, and if you put that into your calculator, you get 5.6568, and it continues on. Then let's see if we can simplify any of these fractions as well. So 4 divided by 3 we can't simplify. Negative 8 divided by 2 turns into negative 4. Negative 12, we know pi is an irrational number. Root 16, so that's 4. This one, the cube root of 125 turns into negative 5. The square root of 3 is 1.7320, etc. This one, next one is 2.466, etc. And this turns into 0.6 repeating. Okay, so that's our first step, is to convert everything. Now we're going to place them. So let's look for irrational numbers first. So anything that has decimals that are going on and on. So our first one we look at here is 4 root 2. Okay, you want to write the original down, not this one up here, okay, what you started with. And then we have pi, and not this one, no. Here we have root 3, and then this one, cube root of 15. So those are our rational numbers, and you can cross them out if you want to. So let's cross out the ones we've used already. Here, 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 and pi. Okay. All right, next we need to place these ones. So we can start with the natural numbers. So remember here we want to have whole numbers, but except for 0. So 2, and then, this one, root 16, because that was a 4, and 19, and that's it for those ones. Next, we want to have the natural numbers, plus we're going to add in 0 here. Okay, now we're going to add in any negative numbers. So negative 8 over 2, which is negative 4, negative 12, I think that's it. And now we can add in our, we missed one, this one here. Negative 5. 3, negative 125, okay. Now we can add our rational numbers. So we have 0.6 repeating. We have 4 over 3. We have 1.35, that's a terminating decimal. And we have the root of 4 over 9. And that's it. All right, so we've placed all of our numbers. Next question is true or false. It says, state whether each statement is true or false. Every integer is a natural number. So we have to look up here. What's our definition of an integer? Integers are negative counting numbers, 0 and positive. Natural numbers are the counting numbers. So is every integer a natural number? No, the negative ones and the 0 are not natural numbers. So this one is false. The next one says all whole numbers are integers. Okay, so here we have whole numbers, 0 and the counting numbers, and then we have integers, negative, 0, and the counting. All right, that one sounds good. So that's true. Every real number is a rational number. So here we have, where are the real numbers? Here are the real numbers. That's all numbers and is a rational number. So that's not true because some real numbers, if you look here, it splits off. Some real numbers are irrational. They're not all rational. So that one would be false. consider the list of numbers. So we have a list of numbers, and then it wants us to list all the different types. So if we're going to do that, first we need to go through and see if we can simplify. So this one is already as simple as it can be. Root 17, though, we can simplify to be 4.123, and it continues on. 13 is fine. Negative root 25 becomes -5. And then this one is repeating, or just a lot of decimals. So we're going to list our natural numbers. So we just want counting numbers. So here we have 13. Cross that one out. Next, we want whole numbers. So remember, if we look up here, for this first set, natural, whole, integer, rational. So these are all nesting one inside the other. So that means that if something's in the natural numbers, it's a whole number as well. So we're going to add the 0 to this, and we still have our 13. Next, integers. So now we're going to add in any negative numbers. So we still have 0 and 13, but we're going to add in our, so we'll write 0, 13. We have -4 to add, and we have negative root 25, which is -5. We have those to add in. Next, we have the rational numbers. So we're going to write everything we have so far, 0, 13, -4, negative root 25. And then we're also going to add in, here is -1.3, so terminating decimal, 0.7 repeating, a repeating decimal, an actual decimal, 3/5. And that's it. Then we're going to have our irrational number. So this time we're not going to include everything else. This is a separate branch. So we have root 17, and then we have 3.232, etc. Those two numbers. And for real numbers, you could write a list of every single one, or you can just write all, because it's all the numbers listed. Question 4, state the number system each of the following belongs to. So here we have the cube root of 125. So first we need to simplify. Can we simplify cube root of 125? We can, it's 5. So 5 is a counting number, so it belongs to natural, and then it belongs to everything under that. So whole, integer, rational, and real. So it has a lot of different things. Next one we have 7.59 repeating. So that's a rational number, and it's also a real number. And then this one here, square root of 27, that comes out to be 5.19615, etc. So this is an irrational number, and it's also a real number. So they have to always at least have, everything's going to be real, always. And then there's at least going to be 2 categories because they're all real, and then it splits into irrational and rational. And then from there, if it's irrational, it could be more categories as well. All right, so that's it for this lesson.